Assalamu alaikum everyone. I hope you guys are doing well. So in today's video, I will be solving some past paper questions regarding the use of modulus. So we've done the concept, and today we are going to look into some full-length past paper questions. So here's a question. Let's see what it says. So it says a function f is defined by f of x equals to 2x minus 3 inside the modulus minus 4. And in the first, we're given a certain domain, which is from -2 to 3. And in the first part, we're supposed to sketch the graph of y is equals to f of x. Okay, so let's do that. Remember the procedure to sketch any modulus linear function. Okay, so not just any modulus function, but a modulus linear function, which means that inside the modulus, you have the equation of a straight line. So the first thing you want to do is you want to find out the x coordinate of the vertex. So keep your eyes on the prize. That's what I like to call it, that it's either going to be like this or it's going to be like this. So essentially what you want are 3 points. So one is the vertex and the other is the starting point and the end point. Okay, so it's like you're making a triangle. You know that you want 3 points. Once you have the 3 points, you can join them and make not literally a triangle, but you can make something like this, or perhaps something like this. So how do we find out the x coordinate of the vertex? Here's what we do. Whatever is inside the modulus, we equate that to 0. So let's equate 2x minus 3 to 0, and we can solve for the value of x, which is equal to 3 upon 2. Then if you plug this back into the modulus functions and to find f of 3 upon 2, we know that whatever is inside the modulus will come out as 0 because we equated that to 0 and we got x equals to 3 upon 2. And then minus 4. So that means the y coordinate of the vertex will be minus 4. So we have what we need, the coordinates of the vertex, and they are 3 upon 2, comma, negative 4. Okay, so what's the situation like right now? Right now, this is what it looks like. Remember, it's a sketch, but still, we're going to try and be as accurate as possible. So 3 upon 2 means 1.5. So that means if this is 0, this is 1, this is 2. So 1.5 will be somewhere over here. And minus 4. So let's say this is 2, this is minus 4. So 3 upon 2 minus 4 is going to be somewhere over here. Okay. Now, next thing you want to do is you want to plug in the endpoints. Okay. So what do I mean by that? That means let's plug in minus 2. So if I plug in minus 2, let's see what happens. So 2 times minus 2 minus 3. Let's try and not use a calculator till we feel like we absolutely have to. So 2 times minus 2 is minus 4. Minus 4 minus 3 is minus 7. Modulus of which will be 7 minus 4. So 7 minus 4 equals to what? Is equals to 3. So that means if I plug in minus 2, which will be approximately somewhere over here. So this is minus 1, this is minus 2. What do we get? We get 3. So 3, let's see where 3 will be. 3 will be somewhere over here. So this is what it looks like. Now we want the other point so that we can complete the modulus graph. How will we get the other point? We'll get the other point by simply plugging in 3. So let's plug in 3. So that would be 2 times 3 minus 3 inside the modulus minus 4. So 2 times 3 is 6. 6 minus 3 is 3. Modulus of which will also be 3. So it's going to be 3 minus 4, which is equal to minus 1. So that means when you plug in 3, you get minus 1. So 3 will be somewhere over here. And when you plug in 3, you get minus 1. So that means this is what the graph looks like. There you go. That's it. Job done. Then the question says state the range. Okay, so now that you have the graph, stating the range is even easier. So you can see that the minimum value is minus 4 and the maximum value is positive 3. So that means the range of f is greater than or equal to minus 4 and it's lesser than or equal to 3. Now, why are we considering 3 and why are we considering minus 4? That's because both the endpoints are included. Minus 4 will be included whatsoever because it's somewhere in between. But why are we considering 3? Because minus 2 is part of the domain. That means 3 will also be part of the range because there's an equals to sign. So that's that. Then part 3, solve the equation f of x equals to minus 2. Now, before you actually solve this equation, I want you to, be one step ahead. So when you solve f of x equals to minus 2, that means you're technically finding the point of intersection between the graph that you've already drawn and this horizontal line over here. So looking at the two lines, looking at the two graphs, we can see that we should end up with how many points of intersection? We should end up with 2 points of intersection. If you don't end up with 2 points of intersection, that means we've definitely done something wrong. So this is how you can be a step ahead of the question. So we have f of x, which is 2x minus 3 inside the modulus minus 4, and we need to equate this to minus 2. So let's take minus 4 across the equals to sign. So 2x minus 3 inside the modulus is equals to minus 2 plus 4, which is equal to positive 2. Now what happens when we remove the modulus? 2x minus 3 is equals to 2, or 2x minus 3 is equal to minus 2. Now what happens if I solve this? 2x is equals to 5, x is equals to 5 upon 2. Does that make sense? Yeah, it does make sense. One solution does seem to be somewhere in between 2 and 3, so that means probably 2.5. But we can't, take the solution from the sketch because it's a sketch at the end of the day. So 2x is equals to 1. That means x is equals to 1 upon 2. Does that make sense? Yeah, that also makes sense. 1 upon 2 means 0.5. And from our sketch, we can tell that it's got to be in between 0 and 1. So what better than 0.5? So that's it. That's the answer to part 3. How many marks? 3 marks. I think that's a great deal. So yeah, you're lucky there. If you're lucky if something like this comes in past papers. Then it says a function g of x is defined by so and so for minus 2 to k. State the largest value of k for which g has an inverse. Now remember, what's the condition for inverse? A function will have an inverse for as long as it's a one-to-one function. So one-to-one function, as we know, is a function that's constantly decreasing or constantly increasing. It's not doing both. So as it is right now, it's not a one-to-one function. It's a many to one function. Okay, there are many values of x that give you the same y value. Like for example, this value of x and this value of x, they both give the same y value. And we saw that, there are two values of x that give the same y value. So if we start from here, because it says from minus 2 to k. So from minus 2 onwards, it's a one-to-one function. It's a one-to-one function. Why? Because it's decreasing, 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 decreasing up until this point. Okay, and after this point, it starts to increase. That means from this point onwards, it's no more a one-to-one function. And what's the x-coordinate of this point? We just worked it out. It's basically 3 upon 2. So that means the largest value of k for which it has an inverse is 1 upon 2. And there you go, one easy mark. Now, next part. The next part says, given that g has an inverse, express this in the form of ax plus b. Okay, express g of x in the form of ax plus b. Now, be a little careful that this entire function does not have an inverse, okay? It's only this part of the function which has an inverse, okay? Now, what does this part of the function look like? This part of the function is basically a straight line, but what kind of a straight line? It's a downward sloping line, okay? So this part of the function is a downward sloping line, and we need to express g of x in the form of ax plus b. Okay, so it's basically the left-hand side of the function. Now, left-hand side of the function basically means that it's a downward sloping line. And if I take 2x minus 3, that doesn't make any sense. Why? Because 2x minus 3 minus 4 is basically for this part of the graph, okay? So what about this part of the graph? This part of the graph will basically be the minus of the modulus, meaning that for this, remember, whenever you move modulus, it's either plus or minus. But since we're talking about this part, the left-hand side, which is a downward sloping line, that means this is the part of the modulus which we get when we multiply it by minus. So that means this is what we're looking at. So for part 5, since we're talking about the left-hand side, that would be 2x minus 3 minus 4. We know that with modulus comes plus and minus, okay? But this part is the one that comes with minus. So minus 2x minus 3 minus 4. So it's going to be minus 2x plus 3 minus 4. So that means minus 2x minus 1. Okay, and what are we supposed to? Are we supposed to find inverse? Okay, no, we're not supposed to find the inverse. That's it. This is what we want. And this is basically the function which has an inverse. Now I'll give you an alternative way as also. What does this look like? It's a straight line. So if I want to find out what this function is, I can simply find out the equation of a straight line. Okay, that means I can use these 2 points or any 2 points, minus 2 comma 3 and half comma minus 4, and find out the equation of a straight line. And this is exactly what you're going to end up with. Okay, but if you want to save some time, then you can use this trick that, in modulus, we always have 2 straight lines. So one is with the positive sign, one is with the negative sign. This is the one that comes with the negative sign. Okay, so I hope that's clear. Now let's move to another question. Now this is a question, I've chosen this question because here, the function that we're supposed to sketch, we're supposed to sketch, that's great, is basically not a linear function. It's a quadratic function. So the way that we do that, the way that we sketch a quadratic function, which is inside the modulus, is basically the way that we sketch a normal function, and then we apply the modulus, which means if there's anything that's below the horizontal axis, we reflect it above the horizontal axis. So let's see how this is done. So it says the function f is defined by so-and-so for a certain domain by first considering the stationary value of the function. Stationary value basically means the x-coordinate of the turning point. Show that y equals to f of x has a stationary point at x equals to 4 and determine the nature of the stationary point. Now, if you've done differentiation, you can use differentiation. If you haven't done differentiation, you can use completing square. So let's use completing square because I'm sure everyone has done completing square. So x squared minus 8x, we leave a bit of space, then we write plus 7. Now, what do we add over here? We add the square of 4. Why 4? Because 4 is half of 8. And if you're adding something in an expression, that means you got to subtract the same thing from the same expression also. So this part of the expression becomes x minus 4, the whole thing square. 7 minus 16. What's that? I guess that's minus 9. Yeah, that's minus 9. So there you go. We can see that the coordinates of the turning point are 4, comma, negative 9. So we have proven that at x equals to 4, it's stationary, and we are supposed to determine the nature of the stationary point. So by nature, this is a minimum curve. So we'll say that this is a minimum point. And there you go. That's the answer. Now, in the next part, we're supposed to sketch the graph. Okay, so how do we sketch? Now, notice that the question has made us find out all the relevant information in order to draw a sketch, and let's use that information. So the turning point is 4 comma minus 9, and remember we're sketching the graph of f of x, so this function right here. Now let's keep this in the center because we might need room on both sides. Let's start with the turning point. So this is 1 2 3 4. Okay, and minus 9. Let's say this is minus 2, minus 4, minus 6, minus 8, minus 10. So 4 comma minus 9 means that it's going to be somewhere over here. So we know that this is the point where the curve turns. Okay. Now, then what about the y-intercept? The y-intercept is 7. So 2, 4, 6, 8, 10. The y-intercept is 7. Now, what about the domain? If you look at the domain actually will not allow the y-intercept because y-intercept means x is 0. The domain is from 3 to 8. So let's plug in 3. Let's use a calculator. Okay, and we're going to plug in 3 with the modulus sign as is. Okay, so, or if you do it, okay, you know what? Let's plug in 3 without the modulus sign just so that we can see how modulus impacts the graph. So f of 3 would be 3 square minus 8 times 3 plus 7. Okay, let's see what we get. So we get 3 square minus 8 times 3 plus 7. So we get minus 8. Okay, now let's keep it as minus 8 for now. Don't worry about it. So if you plug in 3, you get 3 square minus 8 times 3. So that is minus 8. So that means at 3, we get minus 8. So something like this. Okay. Now, then let's plug in 8. So if I plug in 8, so this is 5, 6, 7, 8. So if I plug in 8, I think we're going to get 7 because 8 square minus 8 times 8 will cancel each other. Yep, that's correct. And we get 7. So somewhere over here. So this is what the graph looks like. This is what the graph looks like. Let's do that again. Okay, no, let's do that one more time. Notice the question did not ask us to show the x-intercepts. So that's why we haven't done that. Okay, that's more like it. Now, obviously, this, we can't leave it over here because remember the actual graph is with the modulus sign. Now, what happens when there's a modulus sign? Here's what happens. So 3 comma minus 8, this point will now become 3 comma positive 8. Okay, so once modulus is applied, this part of the curve will be reflected above the x-axis. 4 comma minus 9 will become 4 comma positive 9. So it's going to be somewhere over here. That means now this part of the graph remains as is, but the part which is below the x-axis will be reflected above the x-axis. So that means now the actual graph looks something like this. And there you go. That's it. That is what the graph really is. I know it might seem a little weird, but that's how it is. And in the end, don't forget to either erase the part that's below the x-axis or make it dotted. Okay, you can make it dotted also, but if you want, you can erase it altogether as well. So yeah, there you go. That's the answer. Now, let's see what the next part says. The next part says find the range. So, that's quite predictable of the examiner to ask us to find out the range because the examiner has done everything necessary for us to be able to do that now. So the range means the highest and the lowest value. So let's identify the highest value. The highest value is 9. The lowest value, as you can see, is 0. So that means the range of this graph or the range of f will be greater than or equal to 0, lesser than or equal to 9. Let's see if that's the correct answer. Yep, that is the correct answer. Is 9 included and 0 included? Yep, they're both included. Okay, now part 4. The function g is defined by, so it's the same function for the domain 3 to k. Determine the largest value of k for which g inverse exists. So the largest value of k for which g inverse exists from 3 onwards. So remember, inverse will only exist for as long as it's a one-to-one function, which means for as long as it's only increasing or only decreasing. If it's doing both, it's not a one-to-one function, it's a many-to-one function, therefore no inverse. So the function is increasing, 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 increasing up until it reaches the turning point. Now, what are the coordinates of the turning point? The coordinates of the turning point are 4, 9. So that means the greatest value for which the inverse exists is from 3 to 4. And that's it. That's the correct answer. Okay, let's do one more question. Here's the question which we're going to solve. Let's see what this is. So these are the kind of questions that you get lately. You're given the grade, everything's nice and smooth, and you don't have to, make messy sketches like these. Although, I mean, this is the trend lately. There's nothing which says that, this is the kind of questions that we have in the syllabus, but this is lately what the trend has been. So let's solve this question. On the axis below, sketch the graph of y equals to modulus 6 minus 3x, showing the coordinates of the points where the graph meets the coordinate axes. Okay, so here the question wants us to show that explicitly. Here the question didn't mention any such thing. So that's why we didn't. And, there's a good reason for the question to not mention that because there's literally just one x-intercept. There is no y-intercept and there is no other x-intercept either. So here we have to pay extra attention to the point where the graph cuts the x and y axis. So as always, we start with finding the x coordinate of the vertex, which means equating 6 minus 3x to 0. What's x equal to? X is equals to 2. If you plug that back into the function, you will get 0. So that means the x coordinate, the coordinates of the vertex are 2, 0. Now, there is no range that's given. So here's what we're going to do. We're going to take the endpoints, as in there's no domain that's given. So we're just going to take the endpoints of the grid. So we'll plug in 6. Let's see what happens if we plug in 6. If I plug in 6, so we have y is equals to 6 minus 3 times 6. 3 times 6 is 18. 6 minus 18 is minus 12, square of which is 12. Okay. Now, if I plug in minus 2, so that means 6 minus 3 times minus 2. So 3 times minus 3 times minus 2 is 6. 6 plus positive 6. 6 plus 6 is equals to 12. So that means minus 2 also gives us 12. Okay. So now let's also find out the y-intercept. Okay. So a good idea would be to find out the y-intercept because there's no guarantee that if I draw these two, actually we will get the exact y-intercept, but let's do that. Judging by the straight line equation, we can tell that it's 6, but let's do it anyway. Let's do it formally anyway. So y is equals to 6, which means y is positive 6. So here is the first half. There we go. And here's the second half. That's it. Job done. Solve 6 minus 3x is equals to 2. So you can see, be a step ahead that we should get 2 points of intersection, maybe 1.5 and 2.5, but let's find out. So 6 minus 3x is either equal to 2 or, remember, when modulus sign is removed, we use a plus minus. So 6 minus 3x is equals to minus 2. So technically, the modulus sign, when you remove it, the plus minus comes from where you remove the modulus sign, but we sort of skip that step and we straight away take it with the constant because that's what you will eventually have to do anyway. So 6 minus 3x is equals to 2. And let's understand why there is a plus minus sign from where the modulus is removed, because one equation you're solving where this line is equal to 2, and the other equation that you're solving is where the other straight line is equal to 2. Okay, so that's the reason why you have a plus minus from where you remove the modulus. So 6 minus 2 is equals to 3x, which means 3x is equals to 4, which means x is equals to 4 upon 3. So that means 1.333. That makes sense. Our graph confirms that the point of intersection should be somewhere in between 1 and 2. And next is 3x equals to 8. So that means x is equals to 8 upon 3. And that also makes total sense. 8 upon 3 is 2.666. Yeah, so that's also somewhere in between 2 and 3. Okay, so we have the point of intersection. And now we have an interesting question, which is that hence, find the values of x for which 6 minus 3x is greater than 2. Okay, so this is 4 upon 3, and this is 8 upon 3. So we want to find out the values of x for which 6 minus 3x inside the modulus is greater than 2. Now, let's imagine the line y equals to 2. Here it is. Now, because the question says find the values of x for which 6 minus 3x is greater than 2, that means we want the range of x where the modulus is above the line y equals to 2. So what's the range of x where this modulus graph is above the line y equals to 2? So you can see that there are two ranges. One is where x is less than 4 upon 3. The other is where x is greater than 8 upon 3. Okay, so you don't really have to solve it like the way we do, because we've already made the sketch and we've already found out the points of intersection. All we have to do now is put the two together and find the answer. So one range is this one, where x is less than 4 upon 3, and the other is this one where x is greater than 8 upon 3. So that's what we're going to say. We're going to say x is greater than 4 upon 3, or x is, sorry, not greater than, less than, because it's on the left-hand side. So x is less than 4 upon 3, or x is greater than 8 upon 3. There you go. That's the answer. Okay. So I hope it's clear, and I hope you guys now are feeling confident about modulus. Remember, no shortcuts. Where there are shortcuts, I'll probably be the first one to give you those shortcuts. But when there aren't any shortcuts, so you better, be mentally ready to play the long game. And if you do that, that's the only way, inshallah, to get everything right. So I'll stop here, and I'll see you guys in class soon, inshallah. So take care. Allah Hafiz.